Okay, we'll go ahead and get going here, and folks can continue to come in as we get started. Hi, everyone. Welcome to the CITP Lunch Seminar Series. This week, we're fortunate to be joined by Michael Madaio. Michael is a postdoctoral research at Microsoft Research, working for the FATE Research Group, which stands for Fairness, Accountability, Transparency, and Ethics in AI. He works at the intersection of human and computer interaction and AI and ML, focusing on enabling more fair and responsible AI through research with AI practitioners and stakeholders who are impacted by AI systems. Michael received his PhD in human-computer interaction from Carnegie Mellon University. Today, he's going to be giving us a talk entitled Towards Human-Centered Design of Responsible AI. Just a reminder that if you have a clarification question related to the talk, please feel free to raise your hand. Otherwise, save any substantive questions for the end of the talk. And without further ado, I will pass this off to Michael.
Fantastic. Well, thanks so much, Amy. And yeah, thanks for having me here. Let's see, are you able to see my screen here? All right, fantastic. Yeah, so thanks so much. I'm looking forward to sharing some of our research on human-centered design of fair and responsible AI. So as you may be aware, data-driven algorithms, or AI, are becoming increasingly ubiquitous in consumer applications like in speech recognition and search, as well as in high-stakes contexts like in healthcare. However, AI systems may have inequitable impacts for different demographic groups, often disproportionately impacting groups already marginalized by society along gender, race, and socioeconomic dimensions, among others. And as prior research has shown, so many of these systems fail to work equivalently for different groups. So these inequitable impacts can take different forms. For instance, they may be harms related to the quality of service that people experience with systems, such as disparities in system performance, like in facial recognition systems, as has been widely reported, disparities in commercial speech recognition, and other examples. They also might result in harms of allocation, as in algorithms that allocate opportunities or resources, such as access to healthcare or hiring or school assignment, among others. And finally, these might also include harms of representation, where certain groups are stereotyped or denigrated or even erased, as in the examples of racist stereotypes of search results identified by Sophia Noble. And in response, people have begun protesting the use of harmful algorithmic systems like facial recognition in public housing, predictive policing algorithms, grade prediction algorithms used in schools, and automated proctoring systems used for high-stakes tests, among others. But all of these examples are protests in response to systems that are already deployed and already causing harm in society. From the other side, in response to this growing critique of harmful AI systems, industry and academic research labs have developed toolkits to support developers of these systems in identifying, assessing, ideally mitigating fairness-related issues prior to deployment. These are tools like Equitas and AI Fairness 360, model cards, FairLearn, among many other tools, metrics, resources, et cetera, for practitioners. But as Ken Holstein et al. Found, this is a quote from their paper from a data scientist saying, well, you just have to put your model out there and then you know if there's fairness issues when someone raises hell. And in their study, they found that nearly half of participants they surveyed had found fairness issues in their products or services, but of those, 99% found issues after deployment, after the systems were already in the world and potentially causing harm to users and other stakeholders who might be impacted by them. So as a result, it's worth asking, where has this current focus on tools and metrics for fairness in AI gotten us? Instead, in my work, I ask, how might human-centered approaches support the design of more fair and responsible AI? So what do I mean by this? So as an HCI researcher by training, I draw on and contribute to theories of human-centered design. So specifically drawing from some prior work from Lucy Suchman and Wanda Orlikowski and others, I argue that AI design and development, like all technology, is situated in organizational contexts of technology production and use. And those contexts can be seen as sites for intervention in fair and responsible AI. And drawing from theories of design justice from Sasha Costanza-Chock and others, people impacted by AI systems should have a voice in shaping their design and in shaping the work of fairness in ensuring that those systems perform equitably for everyone. Informed by this, in this talk, I'll describe two main strands of my research. First, in exploring how the organizational context of AI design shapes the work of fairness that AI practitioners undergo. And then second, recognizing that this work should not be limited only to those practitioners. I'll talk a little bit about research in exploring how participatory approaches might engage impacted stakeholders in responsible AI design. So I'm going to talk today about three studies that represent these or overarching research directions. There's other projects that my collaborators and I have going on in this space, but unfortunately don't have time today to talk about all of them. So first, I'll talk about research with industry practitioners to support more proactive approaches to AI fairness. And this is work that resulted in a paper at the CHI conference on co-designing checklists for fairness in AI. Then, based on what we learned in that study about the role of organizational factors in fairness work, I'll talk about another study that we recently had accepted to the Computer Supported Cooperative Work, or CSCW conference, on how AI teams assess the fairness of their own systems and how that the work of assessing fairness is shaped by the contexts in which they work. And then finally, I'll talk about one project in a larger research direction on understanding this current participatory turn in AI and what might be the roles for stakeholders in participating in fairness work. And this is work with collaborators at Cornell that we presented at a workshop at the NeurIPS conference recently. So first, I'll talk about some research with industry practitioners to support these proactive approaches to fairness in AI. This was joint work with Luke Stark, Jen Wortman-Vaughan, and Hannah Wallach. And I want to go back to that finding about how AI teams often found issues in their products after deployment. And in this project, we sort of started with this as a motivation of, okay, well, what can be done to be more proactive rather than reactive to the awareness of fairness-related harms. And we were inspired by work in other high-stakes domains, like in medicine and aviation and structural engineering, where teams are increasingly relying on checklists to remember and undergo the tasks that matter. In medicine, checklists have cut deaths due to surgery complications by nearly 40%, often by preventing line infections. In data science, more recently, several industry labs and government organizations have started developing checklists for ethics in AI. So these include from Driven Data, DJ Patil et al., Johns Hopkins Center for Government Excellence, the UK's Department of Digital Culture, Media and Support. However, when we reviewed some of these existing resources, many did not appear to have been designed with the practitioners who might use them. And this matters because in other domains, like in medicine, when checklists have been introduced without involving practitioners in their design or in understanding how they might be used, they've been misused or even ignored. So surgeons initially refused to use surgical safety checklists like this example you see here. And in aviation, commercial airline pilots often misused pre-flight checklists, resulting in several high-profile catastrophes. Now, I will say from this example, from the surgical safety checklist, the range of types of prompts varies quite a bit, from simple binary yes/no items, like this is for prior to inducing anesthesia. Has the patient confirmed their identity, or do they have any allergies, et cetera? These are binary, closed-ended questions. But others are more prompts for open-ended discussion and consideration, like what are non-routine steps that they might need? What are these potential critical events? And then finally, before the patient leaves, what are these key concerns? And you'll note here, this sort of caveat at the bottom, it's not intended to be comprehensive, that additions, modifications should be encouraged to fit local practice. This is one after multiple rounds of iteration and work with surgeons and nurse practitioners, anesthesiologists, et cetera. They iterated on quite substantially. And so this informed some of our motivation for this work. So we first investigated what AI practitioners' current processes were for addressing fairness harms. What did they need or want or were concerned about around the use of checklists for fairness in AI? And then finally, how might we co-design a checklist for fairness in a way that fits in, is aligned with their work practices of AI design teams, and is designed with their input for the content, the structure, how it might be used. So to do this, we started with semi-structured interviews with data scientists, machine learning engineers, product managers, designers, and others, and then conducted co-design workshops with participants from those roles, where they suggested items to include for various stages of an AI lifecycle, and iteratively, provided feedback on the items that others had suggested. Across each workshop, each successive group of participants saw the previous workshop's version and iterated on those designs. So following this, my co-authors and I analyzed over 60 hours of audio data, coding those transcripts using inductive thematic analysis methods, and iteratively clustered those into higher level themes and findings. So what did we find? First, we found that industry AI teams often had unstructured approaches to fairness, ad hoc approaches, often largely driven by individual advocates. And those advocates, those individuals on the teams, this often fell to more marginalized members of the product teams who felt like they had to be the one to raise that awareness, having a design discussion. However, we found that there was organizational pressure, incentives to ship products on rapid timelines, and social dynamics on the teams that inhibit that type of advocacy work. So as a software engineering manager told us, well, I get paid to go fast. I go as fast as I can without doing harm. And so we saw this sort of dichotomy in some practitioners' minds between the speed at which they were being asked to develop products and the slow and careful work of identifying potential fairness issues, assessing them, mitigating them prior to deployment. Further highlighting these social dynamics, as one data scientist told us, well, there's no checkpoint where someone's supposed to say something and you have to be this annoying squeaky wheel, and I'm already this annoying squeaky wheel about too many things. So there was both this sort of organization-wide pressure in these incentives and reward structures that promoted rapidly shipping products, and also this social pressure to not speak up about potential fairness harms of the systems they were developing. As one program manager told us, well, the things that aren't processes are the first things to go, given these types of time pressures and social pressures. Doesn't matter what good intentions you have, it's not going to get done to the level of quality as things have a process. Informed by this, as part of the co-design workshops, we wanted to develop this process, this checklist to support conversations among team members, support the work of identifying, assessing, and mitigating fairness harms. And some participants felt that having this formal process, having this checklist could empower them to identify issues without being seen as that annoying squeaky wheel or being labeled a troublemaker. So through the workshops, we co-designed a checklist across 6 stages of AI development, from envisioning what the system should be, what role it should play in society, who are the likely impacted stakeholders, should the system exist at all, should it use AI at all, and ideally, even prior to collecting any data or training any models, trying to identify what types of harm. And some examples that I mentioned earlier, those harms of allocation or the quality of the service the system's providing, trying to identify and envision these potential harms prior to any development and deployment, as well as involving potentially impacted stakeholders as part of that process. As well as defining, identifying potential concerns when they're defining the system architecture, model specifications, like objective functions, loss functions, thresholds for classification, things like that, as well as when defining the data set. So when determining what type of data might be needed and how they might collect it, how it might be annotated at that stage, again, even prior to actually collecting the data, trying to identify potential sources of harm in that data. And then continuing through prototyping and building, asking teams to assess the definitions of fairness that they defined in earlier stages, throughout the process of iteratively prototyping and building, including continuing to engage with users and other impacted stakeholders. But this should not end after launching the product. So we have items for teams to consider and engage in after launching, like participating in public benchmarks or impact assessments, and making sure that their systems were amenable to recourse or rollback in the event that people identified issues with systems, and then continuing to monitor, ideally including both quantitative and qualitative evaluations of their systems in ongoing ways after deployment. Continuing to revisit what fairness means and how it might be measured as the systems are continuing to be used. And this is ideally an iterative process, not something that should be done once and then forgotten, but continue to revisit items from previous stages throughout the process. So in that study, we worked to develop a proactive process for industry practitioners to use to identify potential fairness harms, assess them, mitigate them in their systems prior to development, throughout development, prior to deployment, post-deployment, throughout the whole life cycle, so to speak. But that study only raised more questions. What would it look like for teams to assess the fairness of their own systems in that design process? Those items in the checklist prompted conversations and provided a guide for teams, but what are the work practices that teams engage in? And crucially, what was the role of the organization in shaping that process? Like we heard about those incentives that disincentivized fairness work, but how does that actually fit with the work of assessing fairness in their systems? So I'm going to talk about another paper that we recently had published in the CSCW conference. And this is work with Lisa Ageti, Hari Subramaniam, and Jen Wortman-Vaughan and Hannah Wallach on assessing fairness in AI systems. So in the checklist, several of the key items asked practitioners to define and scrutinize fairness criteria, as well as assessing that fairness criteria. But what does that actually mean in practice? So if you'll recall from the beginning of the talk, I mentioned these 3 high-level categories of fairness-related harms. And I'm going to talk specifically about the first of these, of identifying harms related to the quality of the service that people experience with AI systems. And you might think of this as disparities in system performance. So one way to do this, the sort of dominant paradigm is something known as disaggregated evaluations. And that's a complicated term for something that is fairly straightforward. So many AI teams and other product development teams report the performance of their systems in the aggregate. Maybe that's a single performance metric, or maybe it's an accuracy measure. Things like precision or recall or popular performance metrics, F1 scores, things like that. But they're often reported in the aggregate for all users for their entire data set. However, that can obscure poor performance for particular groups of people. And so this is something that Joy Buolamwini and Timnit Gebru found in their seminal work on gender shades, where they identified that some commercial gender classifiers performed worse for people with darker skin tones and for women with darker skin tones in particular. So they had these intersecting dimensions of disaggregation, where they split apart the performance of the system by different groups. Another example, I think I mentioned this one earlier, Allison Konicke et al. Conducted a similar disaggregated evaluation where they looked at the performance of commercial speech recognition systems and disaggregated them to look at racial disparities in their word error rate, or WER. However, much of this prior work has largely been third-party audits of existing systems, which is incredibly important and has enormous value in uncovering performance disparities. However, it only works, or rather the common approach to this is for systems that are, as in both of these examples, commercially available in widespread use, and as some have pointed out, it is often difficult to put the genie back in the bottle. And so as part of this, we were asking, well, what would it look like for AI teams to conduct these types of evaluations of their own systems prior to deployment? And so there have been some tools and processes that have been developed to support this. So FairLearn is one of these, but there's a number of others. I think I mentioned some at the beginning of the talk. To support this type of work. And you can see just one example here. So this is an open source toolkit that originated within Microsoft Research, but is now fully open source and open governance, where you can see that the overall accuracy of this sort of unknown system in this example here is 83.6% overall. And yet when it's disaggregated or split apart by men and women, there's nearly a 13% disparity in the accuracy. So, okay, there's tools out there to support this kind of work, fantastic. However, as we saw in the previous study in our CHI 2020 work, practitioners' use of fairness tools, resources may often be shaped by their organizational context. So this led us to ask, what are practitioners' processes and challenges when designing these disaggregated evaluations of their AI systems? And then how are these evaluations impacted by the organizational context that teams are working in? So to do this, we started with semi-structured interviews with PMs or program managers from AI teams. First, just to understand, like, what are their existing fairness efforts? What even is the AI system in question? And for some of these that are like assemblages of multiple machine learning models and components in these pipelines, which one or which set of models should we be focusing on here for this study? And then we conducted planning workshops with 3 to 5 members of the same product team together in a couple of sessions where we walked them through a process inspired by Solon Barocas et al.'s paper. First, identifying who the stakeholders were and demographics were, deciding on performance metrics, that they might use in these assessments, and then determining how they're defining fairness, how are they calculating disparities in performance, and what type of data might they collect. So maybe to give an example of how this might look in practice using the Koenigke et al. Speech recognition example. So first, we asked teams to define what are the performance metrics that they're disaggregating for. So in the Koenigke et al. Example, they were looking at the average word error rate, which is a common benchmark in speech recognition systems. And then in our workshops, we asked teams to define the demographic groups to evaluate those performance disparities. For the Koenigke et al. Work, they were looking at racial disparities. And then third, defining the data set that they might use. In the Koenigke et al. Study, they were using a corpus of regional African-American language and Voices of California. And then finally, right, how are they actually calculating those disparities? Okay, so this is the workshop that we had teams walk through. And along the way, we were asking reflective questions, probing questions, trying to observe as much of the process as we could along the way. So who are the participants here? So we had 33 participants from 10 teams from 3 large technology companies. These were teams focusing on text analysis, so things like sentiment analysis, things like that, text prediction, which often involve text generation as part of that, chatbot systems, text and document and meeting summarization, text clustering, fraud detection, security, threat detection, etc. And the participants were a mix of roles, some program managers, data scientists, applied scientists, as well as several UX designers and researchers. So what did we find? First, seemingly simple steps in the process that many toolkits often take for granted in this type of work pose major challenges for AI teams. So as one example, choosing the performance metric to disaggregate often revealed deeper disagreements in values among the team. In that example about speech recognition, I mentioned they used word error rate, but for many application areas, so in text prediction or text generation or chatbots, for instance, there aren't yet universally agreed on, although with an asterisk there on universally agreed on, even for word error rate and speech recognition, but there aren't, I guess, common or popular performance metrics that are widely used for many emerging types of systems, particularly natural language systems. So as one participant told us, our features are judged by usage, but usage isn't a success metric. And what they went on to elaborate is, while usage might be an indicator of fairness issues and performance disparities, it might not make sense to look at disparities in usage or engagement or things like that as a measure of fairness itself. As another team told us, that worked on fraud detection algorithms. In their case, the business customer determines what the appropriate metric to use is. And you might imagine that for algorithms that flag fraudulent transactions, for instance, that some of the, in this case, the business customer, perhaps banks or other financial organizations, might have different preferences or different values for how performance might be measured than people whose transactions might be labeled as fraudulent. And for instance, the rates of false positives, false negatives, precision, recall, those types of choices have implications. And so all of that, which is sort of already going on in the background around how they're evaluating their systems, came to the fore when they were asked to identify and assess fairness issues in their systems, further exacerbated by these existing value conflicts or value tensions. And we also found that for many teams, identifying the demographic group to disaggregate by revealed a lack of representation, a lack of engagement with stakeholders. So for many of the toolkits like FairLearn and others, they assume that participants know what the demographic groups of interest to them are. But as one participant said, well, I don't know what community members that speak that particular sociolect or language variety might want. They knew that, yes, they should agree with speakers of the target language, but as many participants told us, they did not have engagement with those speakers. And often these challenges were exacerbated by the scale at which teams were deploying their systems. So as one program manager told us, well, we don't have the luxury of saying we're going to support this locale or this language. They're asked to do it all. They're scaling up. There's tension that anything that slows that trajectory, the pedal is to the metal. And this was a common theme across all of the 10 teams that we spoke with. And this drive for scale often exacerbated those existing challenges. So for instance, many teams described not understanding what fairness means or what marginalization means in all of the contexts that their systems were being deployed in. So they felt that, well, the problems they're identifying are guided by the perspective of the people on the team, but there could be a disconnect between the scope of those harms that they're identifying and the harms that customers may be experiencing. So this also impacted their ability to collect data across all of those contexts or have access to data that actually looks like the deployment context that they're working in. Many teams told us, and this is somewhat concerningly, that without having this stakeholder engagement or representation of their teams, they often looked internally to use data from themselves or their teams, their companies, to assess fairness-related harms. As one participant said, well, until these privacy issues get reconciled or they get the ability to collect demographic data, their only option is to use their employees' data to assess fairness harms. But this brings major issues because those employees may not resemble the stakeholders who may be harmed by their systems in crucial ways. As many have argued that the demographic makeup of AI teams, the software industry more generally, is often homogeneous and risks reproducing these existing systems of oppression if the designers of AI systems draw on their own personal experiences to understand what fairness means or draw on their own data or data from their companies to assess fairness harms. So what are the implications of this work for fairness and responsible AI? First, that organizational logics, and by that, one aspect of that is the profit motive may lead to priorities for their customers or end users of their systems over other impacted stakeholders who might not be the paying customers. This also leads to incentives for rapid timelines for development and shipping, and incentives to scale their systems across geographic and cultural contexts, despite not often having engagement or representation from stakeholders in those contexts. Across both of these projects I've talked about so far, some of the implications are the importance of attending to the role of organizational logics, institutional forces, and shaping the work of fairness in AI design. To develop resources, processes that are aligned with practitioners' work practices and are situated in sites of technology production and use. And finally, to foster more representation and more engagement with impacted stakeholders in the work of fairness in AI, including identifying the potential fairness harms, involving them in the work of assessing fairness, and involving impacted stakeholders in those decisions around performance metrics and defining demographic groups and potentially data collection and mitigation of fairness issues. So this work has led to several publications, but also has had impact in the space of AI design. So the fairness checklist has been included as part of Microsoft's responsible AI resources and is being used by AI teams within Microsoft and other technology companies. The processes for disaggregated evaluations are being used by AI product teams. And so I'm one of the maintainers of the open source fairness toolkit, FairLearn, and along with some other maintainers, we're trying to incorporate some of these insights from some of this research as part of the educational resources and documentation within FairLearn, even in situations where there may not be computational or technical functionality to automate some of these, which is quite often. So as we saw across both of those studies, the work of developing responsible AI is not only for practitioners. All of the projects I mentioned called for including stakeholders and fairness work. It was something that participants in the checklist study felt was important, that the teams designing those disaggregated evaluations wanted to do, but every team of practitioners felt in the dark about how to do so. So I'm going to talk a little bit about one project, briefly discuss some work here. This is collaborative work with Fernando Delgado, Stephen Young, and Jian Young at Cornell on understanding this current participatory turn in AI design. So there have been increasing calls for more democratic approaches to redesign power dynamics of AI systems. Some of this has resulted in workshops at machine learning conferences and in industry research labs to explore more participatory approaches. But there's little consensus on the goals or the form of that participation, all of which may have implications for stakeholders' power and agency in the process. So this is perhaps new in AI, but in many other fields, there are long-standing participatory traditions. So in HCI, there's methods for user-centered design, value-sensitive design, and participatory design. There's been participatory action research traditions, participatory democracy and deliberation theory involving citizens in developing policy and participatory budgeting, for instance. And in international development, there have been movements and critiques of participatory development research. And generally speaking, proponents argue that participation has normative rationales, that people who are impacted by technology should have a voice in their design, like the design justice tradition I mentioned, and that there are instrumental rationales. That is that designing technologies or policies or research with input from stakeholders might result in better design systems that are less harmful and more fair and responsible. But it's worth asking, investigating empirically to what extent this is in fact the case. So in this study, given the excitement about participation in AI, but the enormous variety in how it is done, we want to first understand like, what's going on in this space, what are the range of goals and approaches to participation, and to what extent do those approaches empower stakeholders. So we conducted a corpus analysis of research articles, 59 articles that use participation in AI. So we filtered out calls for critiques of participation and including those that use such approaches. And you can see certainly some more recent interest in this topic. And then to understand why the authors of those studies took the approaches they did, why did they not take other approaches, what was their sort of more aspirational vision, what challenges did they encounter. We interviewed 12 researchers and practitioners who had authored a paper in that corpus. So to kind of make some sense of this space, we developed a conceptual framework for participation, synthesizing those theories, those traditions I mentioned in other fields. So first, one of these dimensions is the goal. Like, why is participation needed? What is in scope? So what's on the table for participants and who is involved in that? Like who actually is participating? And then what are those methods? Like what form does that participation take? And cutting across these dimensions, based on many of these prior theories and traditions of participation, we identified various levels of empowerment, from consulting to involving, collaborating, and then ideally empowering stakeholders in participation. So first, we found that the majority of current research in this space adopted a consultative approach, largely focusing on designing the user experience of AI, the user interface, the application that the models might be used in, rather than more fundamental decisions about the data sets, annotation decisions, data curation decisions, task or model specification decisions, and more broader fundamental questions about scope and purpose, including whether the system should be built at all or not. And these were things that in the fairness checklist work, we tried to identify as crucial steps along the way. However, it is fewer existing research in this space are engaging stakeholders throughout the AI lifecycle. In addition, we found that for the methods used, that the participation largely involves eliciting input, eliciting preferences from stakeholders, things like questionnaires, interviews, in more sort of one-off interactions rather than more ongoing prototyping, co-creation, and ideally a more sort of reflexive approach to designing like the research questions and how participation should be done, who might be involved. Those were often decisions that were left up to the project team rather than the stakeholders themselves. We found that many of the researchers involved in these studies felt like they were caught between their ideal visions for participation and the more pragmatic reality of how to actually conduct these approaches. As one participant commented that full participation is unrealistic, and according to them, participants, stakeholders have a life to live. Now, this is something that has come up before in participatory democracy, and Francesca Paletta's history of participatory democracy movements. The book that was titled "Freedom is an Endless Meeting," or this idea that participation requires ongoing active commitment. Now, it's not a reason not to do it, but this is a challenge faced in other traditions before. In the AI space, faced with this desire for participation, many researchers describe feeling constrained by the need for rapid publication of results, the need to secure funding, tenure requirements. In industry, feeling like needed to align with organizational priorities, things that we've seen in some of our other prior work as well around fairness. And definitely in this study, we saw, participants sharing the need to include stakeholders from relevant business sectors and markets rather than stakeholders who might be most affected. We saw that grappling with these sort of tensions, constraints between this ideal vision and more pragmatics, several projects used proxies to stand in for affected stakeholders. So these might be policymakers who represent citizens, educators who role play as children, members of tech companies with similar demographics. And as we saw in the Assessing Fairness study, this brings with it its own risks. In other studies, AI teams are relying on algorithms as proxies for stakeholders, where stakeholders might train algorithms, and those are being used to represent or speak or represent their preferences to inform things like resource allocation. And while one might understand how and why people take these approaches to participation, given all of the pragmatic constraints, it's important to note that proxies may not adequately represent stakeholders, particularly as people's interests and needs change over time. And as we saw in the corpus analysis, very few of the studies actually allowed stakeholders to designate who they might want to participate in designing AI. And often that type of identification work was left up to the project teams. Okay, so what are the implications? Let's start wrapping up here. First, we need to empower stakeholders in co-creation of design ideas and giving them veto power rather than simply consulting them on user experience and application and of AI. That the participation should encompass the whole design lifecycle, including the scope for research, identifying research questions, things like that, and consider the trade-offs and risks of representation and who might be represented and how, including those risks of using proxies that I mentioned earlier. So talk today about 3 studies that represent some of these examples. There's other ongoing work that unfortunately I don't have the chance to talk about, but I just want to highlight some of my amazing collaborators' work on inclusive language technologies, work with Jay Cunningham at University of Washington, and some others exciting work going on. And I'm kind of on time here. So some future directions would love to chat about with any of you on some institutional lenses. So what are the implications of these more corporate approaches to institutionalizing responsible AI? Things like key performance indicators that might incentivize practitioners to assess fairness issues, but might bring with them their own baggage or smuggle in their own corporate logics. How might tools and resources for fair and responsible AI support this sort of action at the organizational level, sort of bottom-up work, things like in tech worker organizing, but providing resources, information for the non-technical work of the work of fairness. And then, yeah, how might external institutional forces, things like standards, regulation, interact with these internal responsible AI processes? Yeah, many questions, too many, sorry. This, but yeah, and for the participation work, like how might AI practitioners and impacted stakeholders collaborate together in identifying fairness work, and how might those methods for participation actually disempower stakeholders? So if they're being asked to be involved around technical decisions about feature engineering, objective functions, what types of expertise is needed to engage in that work? And then lastly, how might all of this actually work for AI services or APIs, large-scale pre-trained models, rather than more clearly defined products? So I want to thank my amazing collaborators in all of these projects, and I want to thank all of you. And I think we have some time for questions.
Thank you again, Michael, for joining us, and I will see everyone back here next week.
Fantastic. Well, thanks so much. And feel free, anyone, to reach out if you have any other questions. I'd love to chat. Thanks so much for having me. This is wonderful.